Hi students, today we'll be continuing with the chapter Acids, Bases and Salts. See, we learned what are acids, bases and salts, what is the nature, reason for the acidic and basic nature of substances, etc. in the previous video. Today in this video we'll be talking about the strength of acids and base solutions. We know there are acids and different types of bases. Acids, certain acids we can drink even. For example, carbonic acid and all we can drink even. But certain acids causes severe burns to our body. So even though they are considered acids, we cannot call them we cannot handle them in the same way. That means there is difference in their nature or difference in their strength. So to find out the strength of an acid or a base, we have a new scale called a pH scale. See, we learned that the reason for the acidic nature is H plus aqueous ions and the reason for the basic nature is OH minus aqueous ions. Right? So, if the amount of hydrogen ions present in a solution can be measured by the pH scale, or it is called the universal indicator. Okay, it is available in the form of solutions like this or a paper strip like this. Okay, so and it is showing values from 0 to 14. 0 means very acidic, 14 means very alkaline. Okay, higher the concentration of H plus ions, lower the pH value. See, this scale represents a diagrammatic picture of the concentration of H plus and OH minus ions. See, the blue shaded part is H plus ions, whereas the white part is showing OH minus ion concentration, right? Okay, so see, this left side is having only H plus ions and the pH value is 0. That means if solutions with maximum H plus ions will be having the pH 0. And say as we move from left to right, we can see that the concentration of H plus ions are decreasing, whereas we can see an increase in the concentration of OH minus ion. And when we reach a point like here, where the concentration of H plus ions and the concentration of OH minus ions are almost equal, we call that area the neutral part or the neutral solution. And as we move further, we can see that the concentration of H plus ions are decreasing, whereas the concentration of OH minus ions are increasing, and we reach a point where the concentration of OH minus ions are becoming the highest. That means they are highly alkaline, and the value of pH is 14. So that means 0 means strong acid and 14 means pH 14 means strong base. pH 14 means the concentration of OH minus ions are the maximum, whereas pH 0 means the concentration of H plus ions are the maximum. Okay, so that is pH, and thus it is represented like this: small p and big letter H. P stands for potence. H means potence of hydrogen, the power of hydrogen it is indicating. So pH is showing the power or the potence of hydrogen, right? So this is the strip available in the market, which is sometimes it will be having a light yellow color, sometimes it will be having a light green color. Okay, the picture shows a light yellow color strip, and outside it is showing a scale starting from 1 to 14 it is, but it can be 0 to 14 as well. Okay, and the value also written there on the strip itself. So what we have to do is take a strip from it, dip into a solution for which we want to find the pH, then compare the color with this scale given in the outside. Okay, and we'll be whoever is matching, which color is matching, if that means it is matching like with the this color yellow, then the pH of that substance will be 5. If it is matching with this dark red, then the pH of the solution will be 1 or 0. So this is the exact color it is showing here. Red means very acidic and purple means very alkaline. If the pH is less than 7 means it is acidic, and if the pH is greater than 7 is it is basic. And the color of neutral solutions to pH paper will be green. Okay, so starting from red, and we can see that the color is decreasing to pink, orange, light orange, yellow, pale green, and then green. Then it reaches the neutral solution. Then we can see that the color is increasing, the darkness of the color to dark blue or purple it reaches. Means its basic nature increases, right? So this pH paper or the pH scale helps us to find the strength of the substances given. Then here the table is showing the pH, color of the pH paper as well as the approximate value of the pH. The pH is shown here. For example, first one it is showing saliva before meal. Okay, of course, before meal the saliva, the paper shows green color, which means it is neutral. Or approximate value it is showing here, it is. So it can never be neutral for saliva because some acidity or basicity will be there. After a meal it becomes yellow green, that means it is becoming slightly acidic. Then lemon juice, it shows, the pH paper shows orange color, which means it is pH value is 2.2, means greatly acidic. Then yellow means slightly acidic. Yellow green, carrot and all it's yellow green, slightly acidic. Coffee yellow, acidic. Tomato juice yellow, acidic. Tap water green, which means neutral, but of course it will be having slight variation. Then no, NaOH means dark blue, which means the pH is 14, the strongest base, strongly basic. Whereas HCl shows dark red, which means the pH is 0, which shows it is strong acid. Okay, so these are the color variation you can see in the pH paper, and the corresponding pH values are showing here. And this is the experimental representation. See, this is the way the paper changes its color. See, you can see the color is purple here, green here, then yellow here, red here, like that. And what you have to do is you have to match this color with the scale given in the outside, and we can find the value of pH. And see, it is showing here a gastric juice is strong base, lemon juice strong acid. Okay, lemon juice acid, pure water it is 7, and see the pH of blood is 7.4, means slightly basic. Then milk of magnesia, we'll study about this. It is an antacid which is having a basic nature. Then sodium hydroxide, which is having pH 14. Then it is given examples of some strong acids and weak acids. See, for example, strong, it is sulfuric acid, hydrochloric acid, etc. are strong acids, whereas acetic acid is a weak acid. It's you know what is an acetic acid, right? It's a vinegar. The solution of acetic acid is called a vinegar. Then strong bases, examples are NaOH, means sodium hydroxide, potassium hydroxide, etc. Very strong bases, whereas ammonium hydroxide, calcium hydroxide, we know it is lime. So these are all weak bases. So you have to keep this in mind because we need to find the nature of salt. Then will be required this strength of acids and bases. Okay. Then importance of pH in everyday life. So it is showing pH of urine, it is showing pH 6, intestine pH is 4.7 to 7, saliva pH it is showing, blood pH it is showing, stomach pH, see, it is strong acidic, pH is 2. So first it is talking about acid rain, and we know plants and animals are pH sensitive. So these plants and even animal can survive only in a narrow range of pH change. Our body, human body works at the pH of 7 to 7.8, means it is slightly basic in nature. So if it always wanted to be like this, because lower pH causes many health problems. Okay, then uh, phenomena which is happening in our surroundings, it is showing here the picture. See, the factories and all are evolving, are giving out acidic oxides. For example, here it is showing nitrogen dioxide, sulfur dioxide, etc. So naturally it will go up in the air, it remains there, and when the rain comes, what happens is the rainwater gets mixed up with this acidic oxides. We learned in the previous chapter, acidic oxides mixes with water gives you acids. So what is coming out or what is coming down to the earth is acid. What rainwater containing more amount of or high amount of acids in it. We call it acid rain. Okay, so acid rain we call it when the pH is less than 5.6, means somewhat acidic it is. Then only we call it acid rain. And what happens, what is the problem with acid rain? When this rainwater flows into the rivers, it lowers the pH of the river water. So what happens? It adversely affects the survival of aquatic life. And even to the plants also it causes damage. Okay, so that is a problem with acid rain which are caused by the factories and all. That is the first importance of pH in everyday life. First topic. Then it is talking about soil in our backyard. See, we are can test the nature of our soil in our backyard by collecting a few amount of soil, nearly 2 gram, then dissolve that in 5 ml of water, filter it, take the filtrate and try that solution with the pH paper. Then if the pH is below 6 or above 7, okay, it is we have to do something with the soil, because the ideal soil pH for the growth of plants is 6 to 7. Okay, so that is the importance of pH in every. And we know plants are highly sensitive, or it grows well in the pH range of 6 to 7. Below 6 and above 7 is not good for plants and show some problems in the growth and the yield. Okay. Next topic is pH in our digestive system. We know that our stomach produces hydrochloric acid, isn't it? So during indigestion, so that means if you are having excess food or if you are having some other problems with the, if if it produces indigestion, during indigestion what happens? In order to make it digest, stomach produces too much of acid. So what happens? It causes pain and irritation in the stomach. Okay, we feel a burning sensation in the stomach. So what we will do to get rid of the pain, we will take some antacids. What are antacids? They are containing bases like magnesium hydroxide. We call it milk of magnesia. It's a mild base. What it is doing, it neutralizes the excess acid present in our stomach, causing or giving relief to us. Okay, so this indigestion can be cured, or that burning sensation can be overcome by taking some antacid. What is special about antacid? It is acting against acid. It's a mild base which neutralizes the excess acid present in the stomach, and we get relief from the pain. Okay, so that is pH in our digestive system. Then it causes a pH change, okay, causes a tooth decay. See, we know the tooth enamel is made up of calcium hydroxyapatite, or it is actually a crystalline form of calcium phosphate, and it is the hardest substance we know. We learned in the smaller classes. It does not dissolve in water. That also we know. But what happens when we don't clean our mouth properly? The sugar and the food particles remain in our mouth, react reacted upon by the bacteria present in the mouth. And what happens? It produces acid. And if the pH go below 5.5, if the pH of the mouth goes below 5.5, it causes tooth decay. Okay, so tooth decay is caused by the lowering of the pH in the mouth. If it is below 5.5, it causes tooth decay. So how can it happen? It is happening by not cleaning the mouth properly after food and all. Okay. Now, one more solution is that we use toothpaste. What is special about toothpaste? They are basic in nature. So it neutralizes acid present in the mouth and prevent tooth decay. So regular brushing with toothpaste also reduces tooth decay, so that it keeps the mouth neutral. Okay, that is pH change as the cause of tooth decay. Then self-defense by organisms through chemical warfare. It is showing animals and plants which defends themselves by stinging us. For example, a bee or wasp sting us. What it is doing? It is injecting formic acid or methanoic acid into our body, causing pain and irritation. So what we can do? We know it is methanoic acid or a formic acid. So it can be neutralized by applying a base. So we can use a mild base like baking soda on that area where we got the sting, and it gives a relief. The same is the case with nettle leaf. Nettle leaf is having a small needle-like structures which is causing or which is injecting methanoic acid into our body when we touch it. So what it causes severe pain, burning pain we feel. So what we can do is the either you can apply the juice of this stock pan, which usually found near the nettle leaves, or else you can even apply a paste of baking soda, so that it neutralizes the acid and getting relief. Okay, then it is showing some naturally occurring acids. These are all acids, acidic substances which are naturally occurring, and it is showing the acids present in the substances: vinegar, acetic acid, orange citric acid, tamarind tartaric acid, tomato oxalic acid, curd lactic acid, lemon citric, and a nettle stick methanoic acid or formic acid. Okay, and there is an additional information given: the atmosphere of Venus is made up of thick white yellowish clouds of sulfuric acid. Okay, so clouds of sulfuric acid we can see in the atmosphere of Venus. Then family of salts. So what it is talking about is salts can be acidic, basic, or neutral. Okay, acidic, basic, or neutral. How do we find out whether a salt is acidic, basic, or neutral? The answer is this. When the parent acid and base are very strong, they give neutral salts. But if the parent acid is strong for a salt, okay, if the parent acid is strong, it gives an acidic salt. Whereas if the parent base is strong for the salt, it gives a basic salt. For example, is potassium sulfate. Acid, sulfuric acid, base, potassium hydroxide. That means both strong. So it gives a neutral salt. Here also both strong gives a sodium sulfate neutral salt. This is strong acid but weak base. It gives a basic salt. Strong acid, weak base. Acidic salt, Strong acid, weak base. Acidic salt, strong acid, weak base. Neutral salt, strong acid, strong base. Neutral salt, weak acid, strong base. Basic salt, strong acid, weak base. Acidic salt. So see, ammonium chloride is acidic in nature. Sodium chloride is neutral in nature. Sodium chloride is nothing but common salt or a table salt. Okay, so that is the way to find out whether a salt is acidic or basic or neutral. So what you have to study is which are strong acids and which are strong bases. That you have to keep in mind. Then only we can answer that. Okay. And the pH of salts are given here. See, sodium chloride 7 cc, like this. Zinc sulfate 7, copper sulfate it is acidic. Sodium acetate it is basic. Sodium carbonate it is basic. Sodium hydrogen carbonate also basic, because basic means they have strong base. Okay, now that's all for today, and the next video we'll be discussing the chemicals from common solid. Thank you.